So, hello everyone, good evening. We are starting with the next session today, that is based on the statistics. So, whatever statistics is needed for the data analytics or data science, that part we will cover. Different things are there, like types of statistics, what is it needs, what needs, or why we need the statistics in the data analytics or data science. All these things we will cover in a statistic. We'll start with some basic information related to a stat or a statistics. That is, we'll start with the definition first, or in introduction, we can say what we are doing in this. In actually, we are collecting the data. What we are doing, we are collecting the data. We are organizing it in a particular format. After that, we are analyzing it. So all these steps we will do in these statistics, or we will interpret it and present it in the form of a graphs or a charts like that. That can be understood by anyone. Suppose any non-technical person is there, that also can understand these things. Suppose you want to do some analysis. I just want to predict the sale. Okay, so sale is your output. You just want to predict the next sale, next month sale, next quarter sale. So you should have some data, right? Historical data you should have. We need to organize that data in particular format, tabular format, document format, like that. Like what was the price, what was the quantity, and what was the sale. All these things you should have. We need to analyze this with respect to price, whether there is any relationship with the sale, with respect to suppose that particular period, or if it is was like a new year period, or if it was like Diwali period or festive season. All these things we need to analyze, and we need to interpret some results from it. We need to present that data in particular format. Suppose I can put a line chart. Sale is there and there is a price. So what is this relationship? With increase in price, sale is increase or decrease, like that we need to present it. So generally we are collecting, summarizing and presenting a data. So organizing, analyzing, interpreting, all these things we can consider as a summarizing. So in short, if you want to define a statistics, we can say we are collecting a data, we are summarizing it, and we are presenting in a particular format. So all these things are coming under the statistic, right? So it involves the techniques and methods. So different techniques are there, different methods are there. Those will be used for making a sense of a numerical information. So whatever we are having, that is a numerical information. Price we are having in a new numbers, sale we are having in a numbers. Even there is a diabetic, non-diabetic, like this. Diabetic or non-diabetic, that is my output. Person is a diabetic or non-diabetic, so its output will be 0 or 1 only. If it is if person is a diabetic, 1 I will give. If it is not diabetic, 0 I will give. So every numerical information we will present in the, or we will we will use different techniques or methods to represent that data or numerical data in order to understand the pattern, trends or relationship in various phenomenon. So what is mean by pattern, what is mean by trend, what is the relationship, all these things we need to understand first, right? Pattern, that means whether with something, suppose for a particular period price is high, for a particular period price is going down, again it is high, again it is going down. So if it is following some pattern like this, suppose I can say it is a cyclic pattern, it is following the cyclic pattern like this. So sine wave it is following. If there is increase in something, suppose with increase in the experience, two terms are there, one is experience, one is salary. So with increase in experience, salary increased. So there is some trend, uptrend is there, positive trend is there. Suppose with increase in price, one thing, demand is there, and again on one side price is there. So with increase in price, demand decreases, so nature will be a different. So trend is there. Relationship, we can say there is a positive relationship. With the increase in experience, salary increases, so positive relationship is there. In price, demand decreases, so there is a negative relationship. All these things we need to understand. Is it okay? I hope
Yes,
whatever I am telling, whatever we are discussing, is it clear? if you find any difficulty, if you find any challenging to understand the term, we can discuss more on that part. Okay, I will try to give some examples in between as well. So it is used in a wide range of fields. So everywhere we are using this. Whenever there is a word data, whenever there is a data, statistics will come into the picture. Because whatever data we are fetching, whatever data we are getting, we need to like organize it in a particular format so that we can analyze it, we can interpret some result. We will generally getting the raw data. Whenever we are getting data from somewhere, we are getting the data in a raw format. So by the time you will understand all these things, what is raw data, uh, how it is coming, and how we are like converting it into their particular format, right? So all these things will cover in coming sessions. So science, businesses, economy, sociology, or medicine, and more to draw the conclusions or results and make informed decisions. So at the end, what we need to provide, we need to provide some decisions based on that data so that business can take some, or with help of those insights, business can take some decisions. The if sale is a less, suppose what you predicted, the next month there may be a sale less. So like graph nature is different, or like sometime it was like this and it is reduced at certain level. So how we can increase this, how we can go beyond threshold, how we can go uh, the move on a more target as compared to last month. So all these decisions can business take so that we are providing some uh, recommendations, we are providing some suggestions. So that is our work. So it can it encompasses both. So two types of statistics are there. We will focus on this term. First one is a descriptive statistics, which summarize and describe a data. And second thing is inferential statistic, which draw conclusions and make a predictions about a population based on the sample data. Okay, so I will explain these terms in detail. What is descriptive statistics and what is inferential statistics with the help of example. Okay, so let's see. uh, First we will conclude this. What is statistics? It is a collection of data, then we are organizing it. And organization, analysis, interpretation, we can all these consider in a summarized term. Okay, we are arranging that data, we are doing some analysis, interpreting that results or those results and presenting it in a particular format. Different graphs are there like this. Suppose there is a pie chart. Okay, there is a column chart. If it is a horizontal one, it may be represented in a bar chart. So in order to present it, as of now, in Python we will use matplotlib and seaborn. Matplotlib and seaborn, these two libraries will be used in Python. So Python supports these two libraries for the visualization purpose. In order to visualize this, so in order to print all these charts, suppose 3D chart is there or like this. So in order to give all these charts, what libraries we will use? Matplotlib and Seaborn. Just we will use the date time. We have used the sys module. We have used suppose found tools we have implemented in order to work with the reduce function. Just like that, we will implement Matplotlib and Seaborn for the visualization purpose to represent it. Moving forward, there is next, like last module is Power BI. So that is generally used for the data visualization. So in data visualization, we can use a Power BI or Tableau. So these tools are there in order to work with the data, or in order to work with the uh, visualization, in short, data visualization. Okay, so this part will be we will also cover in our course. Okay, so I hope statistics definition is clear. What we are actually doing in statistics, we will collect the data. We'll have a data first, we'll organize it, analyze, we will do the analysis, interpret the result and present in a particular format which is like suitable. It is not like that data will be presented in a like bar chart only or column chart only always, or only a pie chart. Whatever is suitable visualization or suitable visual, we will represent it in that format. Is it okay till now?
Yes, sir.
Yes, sir.
Is it
Sir.
make a sense? Bhavya,
Yes,
Prema?
sir.
Is it going good? Okay.
Yes, sir.
Now we'll come to the two types of a statistics, that is a descriptive statistics and inferential statistics. Okay, so for that I will give one example. Suppose we are having the data for India. Okay, India as a nation, I'm having data of 1,000 people. I'm having the data of 1,000 people, and what is my target? Height is our target. Okay, we are having the data of 1,000 persons from the India and height, and what I am drawing the conclusion, average height for India's people is a 5.6. Suppose what is average height? 5.6 feet, and the data I have collected from the 4 different states. Data I have collected from 4 different states, like or 4 different states. Yes, suppose Maharashtra is there. Okay, then Andhra Pradesh is there. Then what you can suggest? Yes, please. Okay.
Telangana.
Telangana. Okay, Telangana state is there, and suppose we will take a Tamil Nadu. Is it
Tamil
okay?
Nadu. Yes, sir.
So I'm having the data. So we have collected this 1,000 data from 4 different states. Suppose 300% from Maharashtra, 250% from AP, again 350% from Tamil Nadu. Sorry, Telangana state. So how much it is? And 100% from Tamil Nadu. So is it 1,000? Yes, 1,000 complete, right? So like this, we are having the data from 4 different states. So what I will call this India, I will call, so the whole data is of India only, right now. So this India will be population here. India will be population. Just try to understand this. And these 4 are the samples. What are the samples? Maharashtra, Andhra Pradesh, Telangana state, Tamil Nadu, all these are the samples. How many samples are there? 4 samples. If I calculate the average height of the people of Maharashtra, suppose it is coming as a 5.5. Okay, for 300 people, what is the average height? 5.5. For AP people, it is suppose 5.6. For Telangana state, it is 5.8, and here it is suppose 5.7. Is it okay? Average height of Maharashtra people is a 5.5. Average height of Andhra Pradesh people is a 5.6. Average height of a Telangana state people is a 5.8, and average height of a Tamil Nadu people is a 5.7. Is it okay?
Yes, sir.
So India as a population, states as a samples, right? If I'm saying like this, if I'm drawing the conclusion, average height of India's people, average height of India's people is 5.8. Average height of India's people is a 5.8. On what basis I'm saying this? I'm saying this on Telangana state data. So I'm drawing the conclusion about population based on sample data.
Samples.
I'm drawing some conclusion based on sample data about a population. I'm talking about a population based on one sample, any sample. So that type of statistics, we call it as a inferential statistics. That type of a statistics, we call it as a inferential statistics. If you're analyzing whole data, whatever you are having in a population, whatever you are having in a population, that will come under the descriptive statistics. That will come under the descriptive statistics. So what are the term? Descriptive is related to population, and inferential is related to sample analysis. So it's a population related study. Population related study, but on what basis you are saying it? You are saying it on a base of the sample data. There will be some inference, right? It is not always correct. This is 5.8 and actually is a 5.6. So there is a 0.2 difference. So that we call it as a sampling error. That we call it as a sampling error. So as of now, you just need to understand descriptive statistics is based on the population, whole population, whatever you are having, analysis of the data in the form of a numbers and a graph, total data. So there will be different plots, bar chart, pie chart, scatter plot, histogram, column chart, donut chart, different charts will be there. There will be measures of central tendency because you are working on a whole data. You are working on total data and measures of a dispersion like range, variation, variance, standard deviation, etc. Right? Here you are working on some hypothesis. What I am saying, average height of India's people is a 5.8, but on what basis I'm assuming that, right? I'm assuming that, but on what basis I am saying it? I am saying on the one of the sample, Telangana state sample I'm having with me, and on those basis, so there will be some confidence interval, right? So there is some error always. It is not like you will get the result correct every time. So that type of regression, generally we call it as a regression analysis. We are predicting something based on some data, some historical data. Okay, so descriptive statistics is based on the population, inferential statistics is based on the sample. Whatever parameter that we are analyzing, what we are analyzing, average height or height we are analyzing. So that parameter we call it as a, that parameter we call it as a, or variable we call it as a parameter in case of a population, and in case of a sample, that parameter we call it as a statistic in case of a sample. So average height in case of a population or for India, I will call it as a parameter, and average height in case of a states or a sample, I will call it as a statistics. Yes for a sample, yes for a statistics, very easy to remember. Okay, yes for a sample, yes for a statistics, P for a population, P for a parameter. Is it okay till now? I hope these situations are clear to you, right? Descriptive, population, inferential, sample, statistics, parameter, right? So if you are analyzing whole data, whatever you are having, that will be under descriptive statistics. If you are analyzing some part of it, that will fall under the inferential statistics. Is it okay? Yes, everyone?
Yes, sir.
Then there will be some there is one term that is called as the variables and random variables. What is mean by variable? What is mean by random variable? We just need to understand it. These are the basic concepts. Those will be used in any analysis. Suppose we are following the data science life cycle, data science thing. Then also we need to understand this, right? So how it will work? Just take a look. Variable, that is any characteristic that can take a different value. Suppose I'm analyzing average height. We are analyzing age, temperature, or salary is there, experience is there. It may be input, it may be output, right? Suppose I'm having cholesterol value, right? I'm having blood pressure value. I'm having skin thickness. These different terms are there, and those basis what we are predicting: diabetic, non-diabetic. So all these are the variables as of now: cholesterol, blood pressure, skin thickness, diabetic, non-diabetic. All four are the variables. After that, what comes into the picture? Which is dependent, which is independent. But before that, it is variable. So whatever characteristic that we are analyzing, which are having which is having different values, it may be continuous, it may be categorical, right? Because cholesterol can give you the continuous value, blood pressure can give continuous value, diabetic will be 0 or 1 only, that is a categorical one. Okay, so that is called as the variable. What is independent and what is dependent, that we need to understand now. So cholesterol, blood pressure, skin thickness, on these three input variable, your output is dependent, diabetic or non-diabetic. So I will call these as a input variable or independent variable, input variable or independent variable, or sometimes called as the features. So three different are used for the input variable. On these three input variable, what is depend? Person is a diabetic or not. So input versus output, independent versus dependent, and features versus target. So terms are like this. So if I'm using the features word, that is related to input variables. On what basis your output is depend? Okay, on which basis your output is depend? So target. So target is a diabetic or non-diabetic. Dependent variable is a diabetic or non-diabetic. Or salary I am predicting, price I am predicting. So that will be output variable, dependent variable, or target. So value, its value is independent of other variable in your study. Okay. So cholesterol and blood pressure is not related. Okay. Cholesterol and diabetic, non-diabetic is related directly. So there is some dependency between cholesterol and diabetic. there is some dependency between blood pressure and diabetic. Is it okay? I hope you are getting things.
Yes, sir.
It's a theoretical one. It will take a time. It may take time to understand, but I will suggest you should prepare the hard notes for it, like handwritten notes. So by the time you will get the things, or you can write extra notes as well. If you're getting content from somewhere, just try to add more content, like 20 to 30 pages. You can wind up this all sessions. Okay. Dependent, that means its value depends on the changes in the independent variable. If there is a change in the blood pressure, there will be some change in the output, right? If there is some change in age, age is the input variable. So age will have some relationship between diabetic or non-diabetic. Okay. So that is dependent one. We are drawing some random experiment, random variable. It's basically a function which maps from the set of sample space, set of real numbers. I am throwing the dice, I am throwing the coin, 2 coins I am throwing, head or head tail, so that I can call it as a random variable. Most of the time, we will deal with these two, which are these two, independent and dependent. So that will be our like interest whenever we are working on the analysis. Okay. So this is how we are working with the variables and random variables. So I hope I have explained this. What is meant by population? Population, that means entire group. We have taken the example of India as a nation. Sample, that is a subset of the population that is selected for the analysis. So states we have taken, right? States we have a sample. Whatever is associated with a sample, that we call it as a statistic, and analysis we called it as a, or statistics we called as the inferential statistic. Population, that
Descriptive.
descriptive, and the variable that is associated we call it as a parameter, and type of a statistic, that is a descriptive. So three terms are there: descriptive, inferential, population statistic, parameter statistics, population sample. Okay. So we will get all the things by the time, like whenever you are revising the things, whenever you are like going through it, you will get the things. Okay. So population means, what is the meaning of a population? The entire group that you are interested in studying or describing. So what is important? Entire group. Okay. It could be a people, right? You are analyzing the data of people in order to understand the average height. You can analyze the objects, how many objects are passed in or manufactured in a hour, what is the event. Okay. Sharing a common characteristic, right? So that will come under the population. What is meant by sample? Sample is nothing but a subset of of the population that is selected for a study. You are selecting a Maharashtra state, you are selecting a Telangana state. So you are selecting some part of the population, that we can call it as a subset. So it is used to make the inferences or conclusions, or draw conclusions about the populations. So what you are drawing? You are drawing some conclusion. What I am saying, the average height of India's people is a 5.8. On what basis I am saying it? I have data of a Telangana state people, and based on that I am drawing some conclusion about a population, right? So population means population mean, that means average value, 1,000 people value. For this it will be 1,000. Sample means, that means suppose Maharashtra state, it will be for 300 people or like 250 people, whatever we have selected. So that is generally denoted by X bar. X bar. Okay. So this is how it is denoted, and this is denoted by a Greek letter, that is a mu. Pronunciation is a mu, just like a U. So mu, that is a notation which is used for the average value of a variable across the entire population, and the average value of a variable calculated from the data in a sample. So the sample is denoted by X bar and used to estimate the population mean. So with the help of a sample also, we can estimate the population mean. Okay. So X1 bar, X2 bar, X3 bar divided by 4 samples are there. So we can use that one also to calculate the population mean. Is it okay? All 4 definitions. Any doubt till now? Saranya, Bhavya, Prema.
No, sir.
No, sir.
Okay. Fine. Then something like 3 terms are there again: population distribution, sample distribution, and sampling distribution. Okay. So what is meant by population distribution? So distribution of a variable across entire population. Suppose something is there like average height we are and how much data we are having 1000. So most of the values are around 5.6 suppose. Some values will be 5.1 and some values are 5.9. So less values are on this region 5.1 and 5.8. Most of the values are around 5.6. So nature will be like this. So whatever distribution your data is giving, generally this type of distribution we call as a normal distribution. So what we are checking generally, what type of a distribution your data is following. What is the average height, or like what is the range of that height, or whatever variable you are going through, whatever variable you are analyzing, that we are uh, actually trying to analyze. So distribution of a variable across entire population, it shows the frequency. What it shows? Frequencies or probabilities of different values of the variable within a population. So for example, what we can say, most of the values are in the range of 5.4 to 5.6. So these are the frequencies of the values. Why this nature is like this? Why this graph is going like this? So its shape is like this because in this region, whatever I am drawing right now, in this region, most of the values are there. Okay, whatever I have drawn with a red color, in this region, most of the values are there, and in this region, less values are there, like less density is there. Is it okay? By the time we will get everything, I will try to plot this in upcoming sessions. But as of now, how we need to understand? Suppose on x-axis different values are there: 5.1, 5.2, 5.3, 5.4. If around in between 5.4 to 5.6, its shape is like this, right? It is going upward. So what is its meaning? So its meaning is like in that region more values are there. Out of 1000, suppose 600 values lie in this region. Is it okay now? And other
Yes.
400 like on this side, right? So density or frequency you will get for the population. And if we are doing the same for the sample, so sample distribution or distribution of a variable within a sample, that we can say it shows the frequencies or probabilities of different values of a variable within a sample. So for a sample, we can consider that. So sample distribution we will be used for the sample distribution or for the sample. And if we are dividing our samples with equal numbers, so what is mean by statistic? What is mean by statistics? Just tell me. So such as a sample mean or sample proportion, statistic will be related to sample only, right? Average height, that is the average height from the samples obtained from the multiple samples of a same size, not like 300, 250, 350 like that. So 250, 250, 250, 250 of multiple samples of a same size drawn from the same population. So what is the condition for the sampling distribution? The sampling distribution is based on the samples data, but those samples of a same size. And it shows the frequencies or probabilities of a different values of a statistics across all possible samples, and it allows us to make what it is, drawing some conclusion or inference about the population parameter. So please remember these words. There is a population parameter, sample statistics, based on the sample statistics. Is it okay, guys?
Yes, sir.
Yes. What is the
Here,
yeah, yes. Okay.
uh, here in sampling distribution, it means, for example, before we took the states, Telangana, Andhra Pradesh, like that. For every state, we are taking equal numbers, like,
Equal number of
yeah,
samples, equal number of observations, we can say. In
correct.
every sample, there is equal number of observation. Correct.
Okay, okay.
Yeah. Clear?
If that means for in population means that the number will be varying.
Like in general, like in random distribution, it may vary, right? Generally,
Yes,
it is not like that you will get the similar data
same
for
number in
everywhere,
different states, like that.
right? 250, 250, 250. It may vary, but if you want to if you want to do the sampling distribution, that type, you are not analyzing the whole data. You are just analyzing. Suppose you want to draw the graph for Maharashtra separately, for Telangana states separately. That way, if you want to do the uh, analysis or a statistical data analysis you want to do. So that should be similar one. It is not like 250 here for Maharashtra and you are doing the analysis for 100 data from the Tamil Nadu. So both should be similar, same.
Yes, sir.
Then it comes to the measures of a central tendency. It's very simple to understand the measures of a central tendencies. So whatever, so like somebody can ask you, what are the measures of a central tendency in a statistic? So first one is a mode. First thing first, it is a mode which is giving you the most frequent value, right? Mode is the most frequent value. Suppose data is there, age values I am having, age is equal to different values are there, 10, 20, 30, 40, 50, again 10 is there. Okay, so what will be the mode in this case? Mode, that means the most frequent value. 10 is coming two times, 20 is coming single, 30 is coming single time, 40, 50. So most frequent value is 10 in this case, right? So mode will be 10 in this case. Is it okay? Most frequent value, which is coming repeatedly, like number of times its occurrence is. Suppose occurrence is single, every value is coming single time. There is no repetition in the values. What will be the answer? Again 10. Why? Less value. Whatever value is smallest, suppose it is like this 1, 2, 3, 4. So what will be mode in this case? 1 will be the mode. If it is like this 1, 2, 3, 3, 4, 4, 4, 4. So what will be mode in this case?
4.
Mode will be 4. Is it okay? So whatever
Yes.
just what you need to remember over here, if all values are coming in a same frequency, suppose 1, 1, 2, 2, 3, 3, 4, 4. In that case, 1 will be a mode. Lowest observation or lowest number will be your mode in that case. Okay. Next comes into the picture, that is a median. What is mean by median? So the middle number in an ordered data set. What is the meaning of ordered data set? Suppose your data set is like this 1, 3, 2, 4, then 5 is there. So you need to order it first. It may be ascending order, it may be in a descending order. So what will be the order for this? 1, 2, 3, 4, 5. So it
Descending
may be
order.
ascending, it may be ascending, it may be descending. Both will work because both will give similar result. But what is their middle number? So what will be the median in this case?
3.
Median would be 3. What model will do, actually you are not going to calculate anything, but you need to understand what median is doing, what mode is doing, what mean is doing in a backend. So what will be the median? 3. As these are the odd number of observations, 5 observations are there. But what if there are 6 observations, right? If it is like this 1, 2, 3, 4, 5, 6, right? Data is arranged in a ascending order. So in middle, how many observations you are having? 2 observations. Now you need to take the average of third and fourth. That is third term, fourth term divided by 2. That is 3.5. So this will be a median in this case. Is it okay? For even number of observations, for odd number of observations. We can write a formula also, like suppose how many observations are there? 5. So n plus 1 is equal to n plus 1 divided by 2. That is a 5 plus 1 divided by 2 is equal to 3. Is it okay?
Yes,
So
sir.
third observations I am talking about. So n is a number of terms. It may be 20, 30, 40. Right? So third observations. If now even number of observations are there, what you can write? What you can write? Average of
10. Middle
yes,
2 observations.
middle 2 observations. Right? N plus 1 divided by 2. N plus 1 divided by 2. Then there is some formula. What formula we can write? Formula will be like this. For median, if n is odd, n plus 1 divided by 2. So it was the third term. If n is even, what will be the like median? N by 2. That is 6 by 2. 6 by 2th term plus 6 by 2, 3 plus 1, fourth term. Third and fourth term average. So suppose 30 is at the fourth, 30 is third term, 40 is fourth term, average of that is a 35. 35 will be median in this case. Is it okay? I hope mode and
Yes,
median
sir.
is clear, right?
Yes,
Next one
sir.
is mean. So it's just the sum of all values divided by total number of values. So we can say it is average. So just take 1 plus 2 plus 3 plus 4, 5. There is no need to arrange it in ascending or descending that form. You just need to take average. Just do the additions and divide it by the count or frequency, right? So these three things are there. You need to remember these three measures of a central tendency. What are the measures of a central tendency? What is mean by mode? What is mean by median? What is mean by mean? Why we need to understand this? Because just see why we need to understand this. See, I'm just writing some observations. Age values are there. Simple example we will take. Why we need to understand this? 1, 2, 3, 4, 5. How many observations are there? 5 observations are there. So just tell me what is the mean for this and what is the median for this. I'm not talking about a mode right now. Mode will be 1 only, right? So what will be the mean? 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 5. Sorry, 6 plus 4, 10. 10 plus 5, 15. 15 divided by 5. Is it okay? So it will be a 3. What will be the mean? Average of values will be a 3. What will be the median in this case?
3.
Median. Arrange all the values in ascending order and middle number is a 3, right? Is it okay till now?
Yes, sir.
If our data is like this, age values are represented as, there is some outlier. Outlier means, what is mean by outlier? The number which is
Value that
away
is
from a
not in
given range. It is like far away from a given range, which is not possible. 1, 2, 3, 4, 5, and there is something called as the suppose 100. Right? So generally observations are around 3. Some are like below 3, some are above 3. That type of observations are there, but 100 is above from that range. What will be the mean in this case? Mean will change, right? What will be the mean? It will be suppose 115, 15 plus 100 divided by 6. So 6 1 the 6 and 6 9 the something, right? So 19 point something will be your answer. And what will be the median in this case? Median will be average of
3 plus 4 by 2.
third and fourth term, right? So it will be a 3.5. I hope all of you are agree with this. For 1, 2, 3, 4, 5, mean and median is a 3. For 1, 2, 3, 4, 5, 100, mean is a 19, median is a 3.5. So which change drastically, whether mean or median?
100. Mean.
Mean changes drastically, right? So whenever there is an outlier in our data, our mean is most influenced. Is it okay?
Yes,
So that's why we need to understand these terms. And if I need to replace this 100 right now, I will not use this 100 for my data analysis. What I will do, I will replace this 100 with something, either by mean or either by median. Those are the like available values with I can replace it. So what you will suggest, what I can use, mean or median in this case?
Mean.
Mean or median? Suppose 100 is outlier in my data. So with
Yes.
which value I can replace it? I have two options, mean and median. My mean is a 19 and median is a 3.5.
Mean, sir. Mean.
Mean, right? So
Yeah.
if I replace it with a mean, just take, please pay attention, 1, 3, 4, 5, and what will be the, my
19.
new data set? 19. And if I replace with a median, what will be my data set?
3.5.
Instead of 19, I
1,
can
2,
write
3,
3.5. 1, 2, 3, 4, 5, and my 100 is replaced with a 3.5 now,
3.
right? So which is good? This is good or this is
Mean.
good?
Mean is good.
Mean is good?
When we put in ascending order, no, sir, then also
Huh?
100 will have its own place if we keep mean. If it's median, the place of 100 will be changed when they are like in ascending order or descending order. The place of 100 will change if we use median. If it's mean, it will be the last place all the time.
If it is a mean, it will be a last place always a time, no worry. But just tell me, Saranya,
Yes, sir.
what changing the most? Suppose if I plot this, right? Below 1 and above 1, right? So if I plot this in our like normal distribution, and 3 is your mean, right? So some values will be below this, some values will be below this. Where will be 19 will lie? Still away, right?
It should go up
And it,
again.
not upper, it will lie somewhere in this like right side region. Most of the values are around the mean. 19 is far away. And what will be in this case? Most of the values are around the mean. Still, if you find the mean and median for this, so mean and median will be around the 3 for this. And here, median will be like 3.5 something, but mean will be again shifted, right?
Yes, sir.
So what changing your data? So what I can use? So what was my question? What I can use if I need to replace 100, which is better, mean or median in this case?
In this case,
Bhavya, Prema,
Maybe median, sir.
median.
okay, maybe median, okay, Prema. So you can easily observe as mean is most influenced, median is the less influenced. If I need to replace this, I will go with a median. Just take a median of all this range. Suppose only 6 observations are there, but in my actual data set, there will be 600 observations, 6 observations. So I will take a median of those 6,000 observations and I will replace that 100 with a median of that
Median.
6,000 observations. Is it okay? Clear, Saranya? Or still you are having some doubt?
No, sir. And
Because
like if we consider the graph, the logic you said is right, sir. But again, what I think is if the highest value changes its place, we'll never know what is the highest value, no, sir.
no, first of all, we are finding it. What is the highest value? First of all, you are deciding the range, the difference between maximum and minimum value. So here, obviously, it will be 99, which is not possible, suppose,
Okay, sir.
right? So first of all, we are deciding what is the range. On that basis, we are trying to implement it. We are identifying those outliers. Okay, Prema, you can leave. No worry. Just 10 minutes are remaining. Just go through the recording.
Thank you, sir.
Okay, right? That we are doing first, Saranya.
Yes, sir.
What is the maximum value? Suppose in age column, you are getting like minimum age is 1 and maximum age is a 250.
100.
250 is not possible. So that thing we are doing first. And after that, we are going for the imputing. After that, we are going for the replacement. Okay, just replace that 100 or 250 with something. So what is that something that we need to decide? Whether we are going with a mean, whether we are going with a median, that we need to decide.
Okay,
Is
sir.
it okay? So in actual practice,
Yes,
we will
sir.
get everything, right? But I am just trying to give you the basic scenario, what we are
Okay.
trying to do or what we are willing to do. Okay. Is it okay, Bhavya?
Yes, sir. Yes, sir.
Okay. So next is something called as the measures of dispersion. So measures of central tendency, we just cover mode, median, and mean. These are the 3 measures of a central tendency. Then something out. Okay. What is the spread of that data, right? Suppose if it is like this, data is on one side, right? It is not symmetric about a mean. If it is like this, so suppose mean is somewhere and data is shifted to the right side. So that variability or that spread we are deciding why it is needed. You can see, suppose range we are considering, right? Difference between minimum and maximum value, correct?
Yes.
There are 2 observations, simple, 1 and 9. What is range? 8, correct? For 1 and 9, what will be the range? 8. For 4 and 5, what is the range? 1 only.
1.
But both of these values, you will get the mean as a 4.5. Is it okay?
Yes, sir.
For both of these observations, mean is a 4.5. But what is spread? Spread is more in this case. Spread is less in this case. So that's why we need to understand this. Is it okay?
Yes, sir.
Yes, sir.
I hope you are like getting the logic. Why we are doing all these things.
Yes, sir.
Sir,
We need to understand the spread. Yes, Bhavya.
Can you
Sorry.
repeat this once? Range topic. Can you repeat this once? Sir?
Range.
Yeah.
So whatever observations we are having, the difference we are doing. Suppose here it was 1 and 9. Two observations are there, right?
Okay.
1 and 9. So what is difference between 1 and 9?
8.
8 will be
8.
the range.
Suppose there are another data set, there are two observations, that is 4 and 5. What is the difference between 4 and 5?
1.
1. So in both the case, in first case range is, second case range is 1. But if you see for the both the data sets, 1 plus 9, 1 plus 9, what is 10? 10, that is a 10 divided by 2, that is 5 is a mean. And in this case, 9 divided by 2, that is a 4.5. Just like, sorry for this. What I was trying to explain.
8 plus 1 divided by 2, 4.5.
Yes, sir. Yes, sir.
It should be like this, right? Okay,
Yes.
sorry. Okay. 7 and 1, right? So it is large difference between the like these range values, but mean is coming as a same 4.5, 4.5. It is not like that you are considering mean only, measures of a central tendency only. Though
Yes.
mean is the same, but there may be a spread in, like there may be a larger difference in the spread or in range. So both the things you need to consider. Measure of a dispersion as well as measure of a central tendency. That I'm trying to say, right?
Yes, sir.
Similarly, what variance will give you? Variance that measures the average distance of each data point from the mean. Suppose 4.5 is a mean, right now? 4.5 is a mean. So 1 will lie somewhere here and 8 will lie somewhere here, but 4 and 5 are the closer. So there is like less variance in second data set. There is more variance in first data set. Is it okay?
Yes, sir.
So that variance we are calculating with the help of variance, and if you are just taking the square root of it, whatever variance you are getting through the calculation, square root is known as the standard deviation that we are putting on this normal distribution curve in order to plot the normal standard deviation. Okay, on x-axis we are putting the values of a normal standard deviation from the mean. In that we are considering mean as a 0, 1 standard deviation, 2 standard deviation, 3 standard deviation, that we will see in upcoming sessions. There is something called as the IQR, or interquartile range we are calling it, which is the difference between upper quartile, 75th percentile, and lower quartile, that is the 25th percentile of the data. Simply, what we are doing in this, we are dividing data into the 4 quarters. Whatever data we are having, okay, whatever data we are having, we are converting it into the 4 quarters: 0, 25, 50, 75, and 100. 0, 25, 50 will be at like median level, 75th and 100. So this will cover your 100% data. And whatever data is there between 25 to 75, maximum data will be lie in this range. So that data we called it as IQR. So if your data in this range, what is its meaning? Your data is following normal distribution. So that is the upcoming part. So as of now, you just need to understand the Q3, that is 75th percentile minus Q1, first quarter, third quarter. Okay, first quarter and third quarter. Q1, that is a first quarter, say 25th percentile, and Q3, that is a third quarter, that is a 75th percentile. So whatever difference that you are getting, Q3 minus Q1 is called as the IQR. Okay. Similarly, if you want to calculate the values of variance and standard deviation, you can use these things. Suppose summation of I equal to 1 to n, whatever observations you are having, and each observation like 1, 2, 3, 4, 5. What is the mean? 3. So what you will have? You will have 5 calculations over here. 1 minus 3 square plus 2 minus 3 square plus 3 minus 3 square plus 4 minus 3 square plus 5 minus 3 square. Okay. Each observation subtracted from the mean of the sample divided by 5. So whatever you will get in this case, that will be your variance, and square root of it. Suppose you are getting a 24. So 24, like 4 point something will be your standard deviation in this case. IQR, that is a Q3, 75th percentile minus 25th percentile. In actual practice, you will get this one, IQR. Okay. I hope variance and standard deviation is clear. Yes.
We have to calculate with formulas. That's it, Master.
Yeah. Like actually, we are not going for the calculation. Just how it is calculated that I am saying. You just need to use the NP dot variance. np dot
So
var
we should
np
remember
dot
the formulas, no need.
no need, absolutely no need to remember the formula. But if you're asking me how it is calculated, then I need to explain, right?
Okay.
So
For
that's why
what
I'm explaining.
theoretical we need them.
Sorry.
For a theoretical part only, we need that, right?
Yeah, theoretical part or how it is working, right? So you
To
can
see the
see
logic and how.
variance, that is I'm calculating the difference of each value from the mean, right? Everywhere I have considered the mean. So how those values are spread, that will give me the variance,
Yes.
right? Because it is taking the difference, average of all the difference values, right? As it is squared term. Why it is square term? If it is like this, suppose if this square is not there, you can observe -2 -1 plus 0 minus like +2 -1, it will become 0.
Yes, sir.
Is it? So that's why that square, like in that formula, square is there and summation is taken, right? So this
Yes.
is how it is working. Then it comes to the exploratory data analysis. Generally, this is like major part in any data science life cycle. Starting from collecting the data or from problem statement to the deployment. Most of the things are based on this EDA, and you can observe there is some keywords whenever we are going through some job description for a data analyst or for a data scientist. EDA is the keyword there because we are doing 60 to 70% work in this EDA. In exploratory data analysis, 60 to 70% work of our data science life cycle has been done. So it's approach to analyze the data using the visual techniques so that like person, a non-technical person also can understand it. What we are doing in this, we are discovering some patterns or trends or data we use for the check the assumptions with the help of statistical summary or statistical summary and graphical representations. So generally, suppose 10 million data is there, right? 10 million rows are there. Obviously, we cannot go through all the 10 million rows. We can just give the graphical representation for it. According to category, what is the like sale? According to state, what is the sale that we can give? 25th, suppose we are plotting the pie chart like this: Tamil Nadu, Telangana state, Maharashtra state, and Karnataka, or like that. And it is giving you the like graphical representation. So all these things we are doing in a data analysis. Generally, we are doing all these things. What we are doing in a EDA, these are generalized one. We are doing like more things than this, like missing value, statistic, univariate, all this. Like other than this, also we are doing something. But generally, we are following these things. Suppose missing value is there. You find a empty value or null data. Suppose data is like this. We are having age column and different values are there: 10, 20, 30, and some null value is there: 40 is there, 55 is there, 60 is there, 70 is there, right? So we need to fill this value. It is not like you are having 1000 observations and actually there are only 80 values. So what is its meaning? 120 values are null. So again you need to fill those values. You need to decide with which value we can fill it, whether I can use a mean, whether I can use a median, or I can use a specific value that is suggested by business. So we need to deal with it. So generally we are not going for the removal. We are just going for the filling. We are not removing that observations. We are trying to impute some other value for that. Summary statistics, we can find a mean value. We can find the minimum value, maximum value to understand the data values. What we are getting with the mean, minimum, maximum that we just saw, right? In a range and in the central tendency measures. Okay, univariate analysis, it's very simple. We are analyzing the just one column at a time. Okay, so just age distribution we are taking, or just suppose diabetic on one side, diabetic, non-diabetic, two columns are there, and on y-axis I'm getting the count only. If you are doing the analysis like this, on x-axis you are having some variable, on y-axis generally only count is there, then that type of analysis is called as the univariate analysis. With diabetic, non-diabetic, suppose cholesterol values are there on x-axis, on y-axis diabetic, non-diabetic is there. So on both the axis variables are there. It may be input only, it may be output input. In that format, if it is there, then that type of analysis is called as the bivariate analysis. Two variables you are analyzing at a time. Bivariate analysis. Is it okay?
Yes, sir.
Univariate, bivariate. In data visualization, we can use a different charts or graphs like bar chart, histogram to understand the data easily. Number of charts are there: bar chart, column chart, stacked column chart, stacked bar chart, clustered column chart, clustered bar chart. Okay, generally we are using scatter, histogram, column chart, and pie chart in this case. Okay, so what is the summary till now in exploratory data analysis? In descriptive statistics, two types of statistics: descriptive, which is based on the population data; inferential statistic, that is based on the sample data. Whatever variable is associated with the sample is called as the statistic. Whatever variable that is associated with the population, we call it as a parameter. Very good. Parameter. So we have covered this part: measures of a central tendency, like mean is there, median is there, and mode is there, right? Measures of a dispersion we have covered, like range is there, variance is there, and standard deviation is there, right? Standard deviation is there. So this part we have covered. Next, in upcoming session, we'll see what is probability distribution, Gaussian normal distribution, skewness, what is that, continuous and discrete functions are there, goodness of fit, normality test, homoscedasticity. So these are the things related to descriptive statistics generally. Okay, and in inferential statistics, we are using different tests to give the conclusion about population based on the sample data. So for that, we need to do the hypothesis testing or some assumptions. There will be some error, obviously. Type 1 error and type 2 error will be there. So we'll try to understand what is that type 1 error and type 2 error. Okay. So again, some tests are there. ANOVA, chi-square tests are there. So all these tests we will cover in inferential statistics. Okay. So this part I want to cover today. I hope it's clear. If you have any doubt, you can ask. Okay, Sharanya.
Sir, what is the most possible homework we can do regarding what's happened today?
So most possible homework that you need to write the things. Please write the things. What is statistics? Types of statistics. Okay, at least what is descriptive, what is inferential. If you can add more examples, please try to add it. Whatever slides we are having, right? So we are having these slides. So just take that topic and try to write in your own language. What is statistics? Descriptive, inferential, independent variable. What is independent variable? What is dependent variable? There is no need to go with the random. At least you need to understand what is dependent, what is independent. Population sample, I hope you understood. If you want to write in your own language, whatever language you are finding suitable, like Hindi or like Telugu or like whatever language you are finding suitable, please try to write in that format, because at the end, whenever you are going to revise it, it should be revised in less time. So that is my intention. Okay.
Yes.
So just try to write these things and write in your own language. And these are very important ones: central tendency and dispersion. Okay, what are the measures of a central tendency? People are asking, what are the measures of a central tendency in first round of interview or like in initial stages, right? Dispersion and EDA. What we are doing in EDA, and I just try to summarize these things. So till dispersion, try to write 2-3 pages, whatever like you are finding suitable. So that will be your homework.
Okay.
Yes.
So you said to maintain a different book for this, no sir? Will there be any continuation for Python theory? Python related?
Just a minute. Thank you.